So, our lesson today is going to be inductive, which is perhaps different than other classes or courses. Instead of me sharing content with you, we're going to try to explore or discover that content together. So we're going to look at a few different sets of chemical reactions, and I'm going to ask you to make some observations and draw some conclusions about what is similar across these chemical reactions. And as a quick refresh, we've talked about in previous classes, we have this arrow here that tells us that a chemical reaction is happening. Before the arrow is what we start with, or our reactants. Then after the arrow is what we end with, or our products. And now I just want you, we're going to do this with a few different sets. For this, for each set, I'm going to be asking you to make some observations and then try to draw some conclusions about what is the same across these 6 different reactions in this first set. So what do you see? There's
I
no
don't,
observation that's too small or too big. Anything you see is great.
um, well, uh, I, I don't really know.
Okay, that's great. So I'll start us rolling then. One of my observations is every reaction has an arrow. One of my observations is that all of these reactions seem to have a plus near the beginning. What do you see? What's something that you see? And it could be something that's similar across them, or it could just be an observation like this second reaction starts with an N.
Okay, well, most of the chemicals have little numbers.
Ah, that's a great note.
Not all of them. There's one that doesn't.
Mm-hmm.
Um, some of them have big numbers in front.
Awesome.
And let's see. Most of them contain oxygen.
Ah, great observation.
And
So we're going to try a different set now. And I'm going to ask you to make some observations here. And now your observations can be just within this set, or you can start comparing the sets. I know the first set isn't shown. At the end, we'll look at them all together again. But for right now, what do you see here?
um, instead of a single product on the right side, there's multiples.
Ah, great observation. Great connection.
So, and they're not necessarily all in the same state of matter.
Ah, great observation and connecting to our new content. Awesome. Okay, so now we're going to look at real quick, we're going to look at the 4 sets together. What makes each group different from the others? What do you see that distinguishes one set from the other? You've already started to speak to this in your observations. But what do you see about each set that makes them distinct from the other sets?
They seem to be getting more complicated
Ah, okay.
as we move from A to D.
Okay. And by complicated, is it the same as you mentioned before that there are more things? There are more
Yes,
letters? Okay, cool.
because set A seems like a simple combination of two things to create a third thing.
Okay, great description.
And then B is one thing that creates two things.
Okay, okay.
And C and D are two things that create two new things.
Ah, what do you think then is the difference between C and D?
Mm,
And it's always okay not to be sure.
I don't know.
Okay.
Wait, hold on.
Okay.
Mm, I don't know because that first one on set C is throwing me off
Sure. Why do you think that one is throwing you off?
because that's the only, well, the first and last one on set C are the only ones that have combinations. All the rest of them are single elements.
Interesting. Very, very thoughtful observation. I'm going to now give you some new vocabulary or new terms and allow you to keep digging into that distinction.
Okay.
So, um, these are four descriptions in no particular order, and I want you to match each description with a set. So you can either write this down on a piece of paper or type it in the chat, but each of these descriptions apply to one of the sets. So use all of your observations, everything that you just distilled, to try to connect these descriptions with each set.